conclusion of this class, I'll send each of you a ASPE CEU certificate. And if you have any questions during the presentation, please use the chat feature, and we will answer each in turn at the end of the class. And yeah, so without further delay, I'll pass this over to Todd.
All right. Well, good morning, everybody. Morning-ish. I don't consider 10 morning, but morning-ish. Hopefully everyone's having a good day. We'll get started today. We'll do a little bit of water quality. It's a great topic. Everyone's kind of hearing about it. Well, let me see if I can get Jim's to. Here's the space bar.
You got to click on it first.
All right. All right. So with water quality, there's a lot of stuff out there. There's a lot of stuff. We're filtering, we're softening, we're ROing, we're doing all kinds of stuff with it. So today what we're going to do is we're going to do a real good overview of really filtration. We'll jump into a little bit of water softener. And then we're really going to talk a lot about water descalers and some of the misconceptions and a lot of the rumors out there on what's the difference between a water softener and then a water descaler. What's actually happening with a water softener, how we actually softening the water. And then the big one is when we're using these descalers, and there's a lot out there, what's the actual process? What's happening with my water that you're able to get this process that we can get rid of the scale or make the scale not destroy all the components that we're working with. And then lastly, it is going to be our reverse osmosis. If you've ever heard me do my speeches, I'm not a super fan of RO. It's there, it's got its place, but it's becoming widely popular. I'm getting RO requests constantly. So I'd like to explain a little bit how it works, when you should. Sorry, I'm watching people admit into the room. I'm losing my concentration. But we'll talk a little about what's happening, and then some of the things that are going to need to be done. And then we're going to take all of it: our filtration, our softeners, our descalers, our point of uses. We're going to put them all together and show how, when we build a complete system, we can actually have a water quality system that's going to work well for either your home or your business or wherever you're at. So again, if you guys got questions, again, just hit the chat feature. We'll write those down and we'll try to answer everything at the end. So when we're talking about water and we're talking about water quality, any sort of water quality, one of the most important things to do is test your water. You need to know what we're dealing with our water, because water is different. Anywhere between, we'll just go with Cincinnati and say Oxford. We're only talking roughly about a 40-minute drive, so it's not far away. But the water is drastically different between just 40 minutes. A place that I can run up to, drop something off, come right back. My water is so different. So it's very, very important to test your water. Now, you'll see on the left hand, that's more an electronic, really, really expensive. I wouldn't suggest anyone just to pick one up and buy one, but they're out there. Normally what you would do is you would actually go to a lab. And if you ever talk to me about water quality, if we're getting into like cisterns or wells, that is what I'm going to have you get with. You'll get with a local lab. They will actually physically test it with a computer and break down all the little components. Okay. The one in the middle is really going to be one of our most popular ones. Really what we're doing is we're just testing for our hardness. We'll discuss all of the parameters. Hardness. We'll do some pH. We'll look at some of our iron and our chlorine, but we'll be testing some really good base features on that one. And this is the one I actually use all the time, so we'll even jump in with our TDS, but this is the one I use directly in the middle. The one to the far right, I will tell you, you might as well just not test your water. You're trying to base it off of colors. It'll give you an ish, but nothing that's really going to jump in and tell you, hey, I need to treat my water. So stay away from the little strip areas. They're nice, they're convenient, but they're not going to give you really good data whatsoever. So when we're testing our water, and the first thing we're always testing is, everybody wants to know what the hardness is, and that's because the hardness is what's destroying our products. Everything that you guys are selling or designing or I'm pushing out in the market, when water is extremely hard, the calcium and the magnesium, basically what happens is it's all built into that water as it runs through. All that hardness sticks to the pipes and to our heat exchangers, and even to something as simple as like a solenoid valve on your wash machine. Or if you're dealing with a commercial, maybe you're dealing with a massive heat exchanger, and scale will destroy it. Now, let me also tell you this, scale and magnesium are not bad for you. So don't look at this as we've got to get rid of calcium, we've got to get rid of magnesium because it's making us sick, or it's going to hurt our kids. That calcium is good for us. Magnesium is good for us. When you're my age, you take calcium pills and magnesium pills just to stay alive. So don't think that any of this stuff I'm talking about is bad for you, because it's not. So, but when we are testing for hardness, we're going to come up with a scale. Anything from 0 to 3.5 is what we would consider soft water. Okay. Then obviously it goes all the way up. And the reason I'm showing this, and I've got this laid out, is when we're looking at Cincinnati, I was just sitting in Cincinnati. I tested some water, was sitting around 8 grains of hardness, which it's definitely hard. Definitely looking into some treatment, but it's nothing crazy. Drive 45 minutes to Miami of Oxford. We'll test their water, and they'll be sitting roughly around 32 to 43 grains of hardness. So it's amazing when you're just kind of guessing, like, what is my water? You really want to need to know. And again, the problems, it just really builds up into pipes, water heaters, and appliances. Soap not lathering, I've never really checked that out, but I do believe that women like to wash their hair more with hard water and not the soft water, I believe. I don't know. I don't have enough hair to wash it and even worry about the lather. So somebody else can jump in and answer that question for me. Next one is going to be our TDS, which is our total dissolved solids. Again, what I've done is I've put the scale up here. A lot of it is where we're going to be looking at this, and you test it, and you're like, well, that's awesome. I'm sitting at 400 parts per million here. What am I sitting at? Our target's going to be looking at 500. Okay, and I know I'm giving you all this, and we'll jump into, once we design our equipment, where we want to use different equipment for high hardness or TDS or anything like that. But again, TDS just kind of gives you like a not a good tasting water. I hate to use the word salty, but a little bitter. I would notice more of a metallic. You kind of have like a slight metallic, almost like a coppery taste. If you've ever been in Harrison, Ohio, say 5 to 10 years before today, their copper had a very distinct copper taste to it. And it's just because they had a high level of TDS, which is total dissolved solids. Other one's going to be our pH, and obviously there's not a lot we can really do to raise or lower the pH, but just remember, our pH, we'd like to keep it as close to 7 as possible. pH that is way too low is extreme, it's very acidic and it's going to eat everything out, but also pH that's very, very high turns more into a base and can be just as corrosive and dangerous as an acidic water. So we really want to keep that as close to 7. Really not much of equipment that we can add to it. I'm sure somebody has it. I don't have anything. And I'm really not a big believer in adding any sort of chemicals to your potable water. But a lot of times what you'll be doing is you'll be adding, if you're very high, you want to add some to drop it down. But we need to get our pH levels as close to 7 as possible. The other one is going to be iron. Iron is another one people overlook, and it can be a major issue. We don't have a lot of iron problems in Cincinnati. I do know in the Dayton, Ohio market, we're pushing a lot of iron reduction filters, and we'll discuss why we would put an iron reduction filter in front of our other equipment, because iron just gets in there. It's metal. It tastes terrible, and it's another thing you just don't want to be eating. You just don't want to be chugging it down. You want to kind of get all that out of there. Lastly is going to be chlorine. We have chlorine. Chlorine is, I don't want to say it's good for you, but we have to have it in the water. That's what's going through and kind of helping sanitize, killing the bacteria levels and everything else. But when we start getting to, a low chlorine rate, we have a lot of microbiota. We have a lot of growth inside those lines. And it can, I don't want to say it's going to make you sick. I don't want to scare anybody, but, we just don't want too much of that, the microbials growing in there. Too high, we don't want to drink chlorine. You tell the kids, don't be drinking the pool water. You don't drink the pool water either, because you just don't want to have that much chlorine in your system. So just going over these top 5 are really just your overall base. When anybody calls us or calls me or asks me to help, these are the first targets that I'm looking for. I really want to see what I'm doing with my water by hitting my 5 targets and seeing, hey, where am I at? What do I need to do with the water? And testing your water is going to tell you what we need to do. we've tested our water. We know where we got to be. So now we're going to look at, hey, I'm just going to start off with, I want to filter my water. Okay. Now, one thing I'll tell you is please don't look at this as just an off the shelf. All right. There's a couple things we need when we're choosing the filters. One, I'd really like to have those test results. Now I know what filter I'm going to be going after. But I really like to know my line size. What am I working with? The other big one is fixture counts. A filter that you're putting into a little 2-bedroom home like mine, you don't need a large filter. Now, if you have like a Jim Huseman house, like 14, 15 bedrooms, pools, I mean, it's lavish. It's unbelievable. I probably have to put 19, 20-inch filters just to take care of a Jim Huseman house. So we really want that line size. We really want to get that fixture count, obviously my water test. And now we know it, we got it. Now what can we do with these filters? What are each filters? Because not every filter does the same thing. So let's go over the first top 3 filters that are out there in the market. This is my favorite one. This is the pleated filter. Obviously it's made up of a couple different materials. I really like this because with it being pleated, we have a very, very large surface area. So as the water is passing through all of those pleats, we're actually catching all of that debris down in the pocket and also up the sides and down. So we've given it a huge surface area that we're able to catch any of this debris that's coming through the line. Now, I'll tell you, any pleated filters, really what we're doing is we're just trying to get any sort of extra debris out of the line, any sort of sand, just debris. I hate to use dirt, but it's in our water lines. If you've ever looked inside a water main, you'd probably think twice about drinking out of your faucet. But remember, it's all natural. It's all being built up. Most of it's just calcium and magnesium, everything kind of just building on the outside of the pipes. But that's the things that we're trying to catch with that pleated filter. Also, one of the big ones, most pleated filters, I know if we get into a brand that I represent, their filters, they are able to be cleaned. I normally say 1 time. And the reason I don't say 2 or 3 is as you're in there squirting each one of those areas out, you're weakening whatever that material is. So I would say, hey, with any pleated filter, you can use it you can reclean it. You can clean it. But I'd say just about one time and then toss it. Last thing you want to do is get a big hole ripped in it. And then for the entire 6 months that you're using it, everything's just kind of running through that. So good filter, but only good for basic materials that we're just trying to grab out of the water, more heavy materials. The other one's going to be our melt blown. Not a bad filter. I think it has to be kind of designed and placed in the right area. A lot of times what this is, it's a lot of very, very fine fibers wrapped around itself as a giant kind of tube. It does great. It'll actually pick up more material than your pleated filters. But because it's so tight and it's wound so tight on there, it'll get clogged up very, very quickly. And we'll talk a little bit about it, but when we talk about pleated filters, we'll be jumping into microns, all right? And when we talk in the melt blown, we'll talk about microns, and that's basically measuring the size of the holes or how that water is going to be passing through it. Again, great, but it's very tight. It will fill up quick, and based on your water quality, we want to make sure if we're doing a melt blown, you're going to need more of a preventive maintenance program. You're going to need to change that out more. It does a lot more than a pleated, but it also clogs up a lot quicker. Last one, one of my favorites is going to be the activated carbon. Again, this does a great job. I do not want to use this as a primary filter for debris. What I really want to do is I want to use this to actually change and help out with the taste, the smell, or the color of the water. That's what it really is doing. It really just takes our water quality and just makes it taste better. It just makes it work better with our body. And what we're doing is these are just nothing but, it's more of a burnt coconut. Okay, it's burnt coconut shells packed in there really tight. And as that water is running through, that coconut shell is able to absorb all of that stuff. So we're able to get rid of a lot of those odors and the chemicals. And the big one is chlorine. So if you're living in a municipality that they're adding a little bit more chlorine than what you like, an activated carbon will get rid of a lot of that chlorine taste in your water. So now what we've got, so let's look at our filters. When you're looking at filters, just remember, we need to know what we're filtering. And again, I'm looking for flow rate, stuff like that. with our water test, we're able to kind of figure out what we have. So showing our housing, obviously multiple different housings, but this is a new one that's out there. This is called our Big Bubba. What I like about it though is we can pick our system, and this will do up to 150 gallons a minute. So unless we're on some massive commercial project, this can be dropped right in. And again, if you're on something that's large, 200-300, we can also place these in series. But once we picked our filter, now we're going to come over here to our right, and we need to choose what do we want. Are we looking for a pleated? Are we looking for a melt blown? Are we looking for a carbon? Or the far right, we actually make a pleated carbon combination. A little expensive, but it kind of gives you the best of both worlds. But just remember, each filter does something a little bit different. If we're trying to get debris, jump into that pleated. If we're trying to go after taste, go after that carbon. But don't just throw carbon in just to catch it all. You're just kind of throwing a filter in the garbage really, really quick when it does not need to be. So I'll move on from this, and we'll jump over into the micron. So when you hear the word micron, just remember that is the measurement of the hole. Okay, so we talked about our carbon block filter here, why I like it, but why we got to mess with it here. You got to look on that carbon block, we're only getting a half micron through it. Okay, so you don't want to use that to collect a bunch of rust and dirt and debris because it's going to clog up extremely quick. But if we jump up into our pleated filters, normally off the top of my head, if I'm not sight unseen, I don't know what I'm really doing, I always suggest let's start with a 20 micron, which is technically roughly about the size of a human hair. If you want to get a little better, we can drop down to 5, or you can drop down to 1. But just remember, the smaller the hole, the more you're collecting, which is great. But if we collect too much too fast, our volume drops. We might want to put these more in like a series if we start running into major issues. But again, that test that we do in the beginning is really, really going to help us out knowing which micron we need to choose. I mean, are we going to do a 150, which basically I could almost stick a needle in there, or are we going to drop down to a 1? And again, it's all going to be based on what do you want, or what does the end user want with that water? How clean do they want it? Do they want it bottled water, or they just want to wash their dishes? This is how we choose. It's based off microns and then what material we're using to filter. So now we've got our filtering done, and I think Jim only allowed me an hour, and if you know me, guys, I can talk for hours and hours. Hopefully, guys, this helped out a little bit with filters. Obviously, chat features, or if you've got questions, email us. We'll get everything back to you. Okay, so now we filtered. We've got all the debris and we got everything tasting well. Let's jump into a water softener. What is a water softener? Where should we use it? What is it doing? And the big one, I know everyone's heard of a water softener. If you've never heard of it, you probably are not on this call. But internally, how is this tube making my water have no calcium in it? And that's what I'd like to explain. And that I think if I explain how it works, then you kind of know where to place that object. So again, really like to know that line size. The biggest one for me is fixture counts. One that I don't have on there, but a guy who's been working with me for years, Stuart Mackey, who's really taught me a lot about softeners and water quality, is I got my fixture count, and we'll go to size it, but also with a softener, especially when you get into commercial, we would also really like to know what type of facility, hours of operations, and the reason we're doing that is we'll talk about a 1-tank or a 2-tank system. Okay, we'll talk about that in a minute. But fixture count is extremely important. I'll add in the type of building it is, because again, if we're softening water for, I don't know, say my house versus a hospital, obviously my house, there's some downtime. Hospital, there's no downtime. We'll explain why. Okay. The other big one is we have to have electric. Most of them are going to be roughly about 110 volts, and we need a drain, and not just a drain. We need a drain that is actually operational. We'll talk about how these work, and we'll talk about the amount of water that's being discharged from these when it's going through a regeneration process, which could be every couple weeks, even up to about once a week where we're regenerating. So we need to look at that drain, but also remember, don't just stick it in a little floor drain that's been sitting in a corner and no water's been going down it. You're going to be getting a lot of water down that drain, and a lot of times that's going to happen between 2 and 4 in the morning. So we've got our softeners. We know we're getting all the information. We're going to kick it over to us. We're going to assist you guys on helping size and design. Before I jump too quick, you saw me push over here to a single tank and a dual tank. All right. Just because, when you see single or double, it doesn't mean, well, the double must have extremely hard water. That's not it. When this thing is in operation, and this is where we put in, hey, what type of facility are we working with? Say we're working with, I don't know, a pet store. You know that the hours of operations are roughly between like 8 and 8 o'clock at night, whatever. But when this thing goes into regeneration at 2 o'clock in the morning, pretty much your water will be shut down. So if it's a pet store, a single tank, no one's going to be there at 2 o'clock in the morning. But if we move over, same water, same building, and say maybe it's a little bit of a hospital where there's 24-hour care, we're going to need a 2-tank system. And the only reason you do that is when tank 1 goes into regen, automatically the tank 2 will kick in and provide water. So again, a building that's occupied 24 hours a day, you're going to need to do a 2-tank system, or you'll start getting complaints that between 2 and 4 in the morning, their water volume is almost down to 0. And that's because the water softener is going through a regeneration period. So just make sure that we understand that one. So big one is, how does a water softener work? What is going on inside these 2 tanks that is allowing this water to go from a high calcium deposit water to pretty much no calcium whatsoever? What's happening is, and I know these errors are going to screw you up a little bit, I apologize, water is actually going to be coming in. It'll drop down, and it's actually, forget the errors, it's actually going to drop down this dip tube, run through our screen, and then enter more of a gravel base, okay? Once the water enters that gravel base, it's going to start heading in the up direction, running through our media, okay? That media, you'll hear me using the word ion exchange, and the ion exchange is happening inside of this media base, and I'll explain exactly what's going on. Once the water makes it up through this media, we'll get to the top of the tank, it'll be drawn out, and then sent down to your faucets or whatever whatever we're supplying to that, okay? Now, that's the easy part, all right? So we're able to run water. Water comes up, it runs through all of our media, and what it's doing is it starts collecting, okay? But once you collect, eventually we're going to be full, correct? So if I'm grabbing a bunch of this stuff, it's hanging on. Eventually there's a time where, hey, I've got too much. I'm holding on to too much calcium, too much magnesium. I can't collect anymore. I'm pretty much done, okay? So what's going to happen is we have to go through a regen, all right? And we'll talk about that regen. But let's talk about what's going on with the media inside this tank. What is this media actually doing? How is it grabbing a hold of it? And the word is called ion exchange. All right, it seems very, very smart, but it's just we're exchanging one ion for the next. So when the media is set in the tank and it's new or after a regeneration, what we have is that media is basically we have a lot of sodium ions kind of attached to each individual cell that's out there. So we have that sodium tied to the media. It's just kind of stuck to the outside. But what happens is when the water is entering that tank and it drops down, we have a lot of calcium, which is our Ca+, sodium is the Na, but we'll have calcium and magnesium. What's going to happen is on the exchanges, our calcium is going to come in, hit that media, and stick to it. All right, once it sticks to that base, as soon as it sticks to it, now what we have is that sodium ion is now released. All right, so there's your exchange. We're exchanging a calcium ion for a sodium ion, okay? So that calcium and magnesium is going to come in and stick. Say we have 2 sodiums, 2 calciums, maybe 1 calcium, 1 magnesium will stick. The sodium ions will then be released, and that's going to float off into the water. But remember, I have billions of these little media dots running all over, okay? And if you've ever gotten into a water softener, the media is small, it's orange, it looks about the size of a small BB that you would shoot out of a little gun, but I'll tell you right now, that is the slickest thing you will ever step on in your life. So if you ever drop media, you'll know for the next 2 months because you will be sliding on it, okay? So what's happening though is that it comes down and hits, and then it releases, but once we have 2 to 3 calcium or magnesium ions it tied to that media is dead. It's 100% dead. It's not going to collect any more than it already has on it. So over time, eventually, every piece of media is going to become completely saturated in calcium and magnesium. Once that media base is dead, that's it. We're done. We're not going to be softening any more water. The media has gone too far. We're holding on to everything, so it's done. So what we need to do then is I need to get this media up and working. So we're going to go through a regeneration process. And that regeneration process is, instead of dropping down the dip tube, now what we're going to do is we're going to reverse the flow, pushing water down through the media. But what we're doing is we're not using water. What we're using is now our brine, or technically salt water. So now what we're doing is we're taking sodium ions, putting it right back into the tank. The sodium ions are now going to start releasing the calcium ions, but instead of that calcium heading down, what we're doing is we're going to come up and bring that water over and down to the drain. Okay, so what we're doing is all of the calcium and magnesium that's now been released off the media, what we're doing is we're sending it down the drain. And that's what's going on in the regeneration, is we're just exchanging sodium for the calcium to make our water soft, and now we're adding the sodium back to our media to kind of regenerate it and make it new again. Okay, so everyone kind of looks into this now. Our salt and our brine tank. My suggestion, I don't really care about what salt you use. Salt to salt on that end, but use more of a higher cubed, a larger granule. Don't use the chipped or the shave. And the reason I tell people that is, if you have to get into it, but it's called a salt bridge, where the moisture will actually lock the salt together and make it a block. So that's why I say use the bigger cubes when you're working with that softener. Okay. But again, that's all we're doing. We're just exchanging. We're grabbing a hold of calcium and then holding on to it. Then we're taking salt water, reversing that ion, recharging the system, and getting it back working. But remember, when all this is happening, roughly at 2 in the morning, you are getting pretty much about 0 to little to no water will be coming out. So that's why most softeners are always done, set for regen, either up to a gallon or a certain time, and it's done at 2 in the morning. So I'm doing that backwash, and the reason I put this up there, it's kind of a dumb picture. It actually looks like a water heater a little bit, but I put this up there because, again, when we're using a water softener and we got to go through the regeneration period, that drain, we need to make sure it's going to regen for about 2 hours, and you can dump anywhere between 20 and 60 gallons a minute. If it's not on that, on the hours, we may be on times or day. It's all based on how we set it. But remember, if you just throw that regen line into a floor drain that maybe works, maybe don't work, you'll be looking at a lot of water on the project. So make sure that that drain is working. Because at 2 in the morning, that's the last call you want is, hey, my building's flooding out. So now to jump into something a little bit new, and this kind of gives you, I'm getting a lot of questions on our dual media. So now we have dual media, and the only thing with dual media, it looks just like a softener. It's set up just like a softener, but what we've done is now we've added a little bit of both the best worlds. So water, again, will enter down through our dip tube, through our base, up through our media, grabbing onto the calcium, magnesium. But before it leaves and enters up through the house or the building, now what we're able to do is we're actually able to run through an active carbon base. So not only are we able to soften the water, but we're also able to filter and let that granules and those coconut shells absorb all of the the hardness. I'm sorry, it won't do the hardness, but that the chlorines and all the taste and the odors, anything that you got in the water, that carbon activated is really going to help out. So just another system, but you can get them where you get doubles. Now the big one is we're going to talk about a water descaler, or you'll hear the word saltless. I really like them, but there are positions and there are spots that we would want to. Okay. One thing I'll tell you, I think it's even on my next slide. I'll put on here. This is not a water softener. It's not even close. It doesn't do anything to the water, even remotely close to what a water softener does. Okay. What we're doing and what other people are doing with these descalers, there's a lot of different methods. You'll see magnets here. You'll see electric. I even have this, actually is in my house. I've had it in there for about 20 years. It works so well, it's just going to stay there. because I forgot about it. Or you can get up into more of a pellet style or a granule style descaler. Okay, but please remember, these are not water softeners. Okay, if we're running through, say, a magnetic one, okay, if I test my water before, it's going to be hard. If I test it afterwards, it's going to be hard. Same with the electrics, same with these stainless steel tubes that they got out there, or with these one flows. Even my own product, I'm telling you, it is not a softener. When that water enters this tank, it will be extremely hard, but when it leaves the tank, it'll also be hard. Okay, so that's the big one, of knowing what is actually going on inside these pieces of equipment. So when we're talking about a descaler, again, I always ask the same things. Line size, big thing's the fixture count. This little guy up here do 10 gallons a minute. This guy down here do 75. I definitely don't want to push you to a 75 if you only got maybe 8 gallons going through a building. So again, fixture counts are great, but I really want to emphasize, we don't need drains, we don't need electric. So these are systems that you can kind of place anywhere. So it doesn't have to be, if you have a building or a house or a project that has no water softener, no water conditioning, you don't need to have the electrician come in or have the plumber tear up the floors and bring drains over. These can kind of be placed anywhere in the system. So what's going on? And in big bold letters, this is not a water softener. No one can call me and say, hey, I put this in and it's not softening my water. Okay, we have a couple different things, but I'll tell you, when I talk about how this one works versus this one, they're the exact same thing. This is just built for a smaller use. This is more for our higher volume, but this media in the middle is in both of them. And what we're doing is we're using this media to now condition, not soften, condition or descale our water. Okay, and how we're doing that is, well, we talked about the media and a softener that was actually grabbing on and holding on to our calcium and magnesium. Okay, we're holding on tight to it. And then after a certain amount of time or gallons, we're actually going to self-clean it. We're going to regenerate, and we're going to send all of that calcium and magnesium to the drain. Okay, now on a one flow, we're doing the same thing. Water's entering in through the tank. And again, billions of these little tiny one flow medias that are kind of floating around inside there. But the way you want to look at it is it pretty much looks exactly like a golf ball underneath the microscope. It's got little holes and pockets in there. Okay, and what's happening is that magnesium and the calcium's all kind of float around, and what it does is it gets stuck in those little holes, and the media will actually grab onto that media and hold onto it. Okay, after it holds onto it for a while, we call it TACT, with this template assisted crystallization. As you all know, that word is way too big for me to use. So the way I explain it is, hey, it's a golf ball. We're holding on to the calcium magnesium. And what's going to happen is it's going to slowly start to microscopically flake apart. Okay. And what's going to happen is the calcium and now that one flow media is going to start going down your line. Water's still hard, but when it hits the first 90, or say hits the faucet or hits that solenoid valve, because the media is now attached to that calcium, the media is now going to, that water is going to pass through the device without the calcium and magnesium sticking to all of the metal products. And ultimately, that's what we're doing with a softener or a one flow. We're just trying to take the calcium and the piece and the stuff that's in that water and say, hey, please don't destroy the $800 faucet or the $10,000 water heater I put in. Okay, because that's all we're doing with it. But a softener, we're collecting it, releasing it to drain. With the one flow, what we're doing is we're collecting it and then allowing it to flake off and travel through the system and go down the drain. I like it because, again, calcium and magnesium are kind of good for you. So having that in the water is actually a little bit healthier for you than just drinking straight bottled water with nothing in it. All right, you just have to turn around and take your calcium and magnesium pills later. Now, what's really nice, sorry, I got to go back one. How do I go back? There it is. So when we go back to this, it's awesome. You see that system, you're like, hey, we put that media in, it doesn't go through regeneration. My water's still hard, but you know, it's not going to destroy all my fixtures. So what would I use this on? Where would I use this? So originally designed to be in your boiler rooms. You know, we don't care about how pretty and soft the water is and how great the water tastes. inside that boiler room. This product was pretty much brought on the market to protect equipment, to make sure that everything in that boiler room, those mixing valves, the water heaters, heat exchangers, I mean, you guys name it, you've sold it, you've designed it, you've installed it, but all that equipment in that little square room is worth millions of dollars, and we need to protect that. Okay. And this is a perfect system to protect that. Okay. But we look at it as, hey, wait a second, this can be used more than just equipment. What if we use this for more of our drinking water? And that's where more of these one flow pluses, where this media is stuck in this tank. And then what we've done is we've added carbon filters. So just like our dual media water softener, where we can soften it and then filter with carbon, what we've done here on the one flow is now we're able to add our media base and our filter. So we're able to condition our water and treat the taste and the smell of our water, because we're going to be using this for drinking now. So we'd like it a little bit better than just kind of kicking out and just saving the equipment on that one. One thing with this media, okay, this media is great, and it's good for up to 3 years. Okay. Now we talked about that little ball, that little golf ball that's collecting the calcium and magnesium on that one. But as it microscopically flakes away, obviously anything that's breaking down, that's going to get smaller. So what we'll tell you is if you're using a one flow, either the plus or you're using just our one flow tank, and again, it's up to 75. We can get you 30s, 50s, whatever it is. But that media needs to be replaced every 3 years. Okay. And the reason we're doing that is at 3 years, that little piece of media in there is just flaked away enough that we're saying, hey, it's not good. And the great thing about it is this tank is not filled to the top. It's only about 25% full. So to change that media, we have 2 unions, unscrew the head, the whole thing pulls out. I normally would just take this, dump it into a 5-gallon bucket, and then just toss it. It's not biohazardous, so you can just throw it right away. But to change the media out on a system like this, by shutting the water, loosening unions, bringing it out, you should probably have roughly, first time 30 minutes, you'll get a little quicker afterwards. But that will be also the same with more of our light commercial residential. It's just that media, that media, we want to change that out at least once every 3 years. We don't, if we don't have it, it's no good. So get that replaced either with our cartridge or adding into the tank. But please, 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 please write down one note for me. Don't tell anybody or put in your mind that one of these systems, these conditioning systems or softeners, will be very, very, very disappointed. So the other one, this is the RO. RO systems are great. If you want perfect water, this is what you're going to need. If you want water with nothing in it, this is what you need. Okay. Because what we're doing is we're going through multiple different stages of filtering, and we're actually going to be combining. What's going to happen is we're going to be going through multiple stages when we're going through all of those filters to pull out. Now, one thing I'll tell you is with RO, you need to know what is actually going on. It's a huge uptick, and I'm very happy to sell as many RO systems that we have, but knowing what RO water is and what it can do and where it technically should be used and where it should not, I think is very, very important. So when we're talking about an RO, it's reverse osmosis. And just remember, you're going to see a lot of these numbers down here. That's gallons per day. Okay, so we have systems, we can do 30 gallons per day all the way up to 10,000, 8,000 gallons per day. This is not a gallons per minute. It takes time. Okay, it is a very slow process. But when I explain the process, you'll understand. But it has to be slow. It cannot be just zing through that filter and it's RO water. It takes time, so it takes a while to build up 30 gallons per day out of a small system. It takes a long time to get 10,000 gallons through one of these systems because we are bringing it down to its purest form that you can get. Now, what's it good for? It's good for pretty much everything. All right, it pretty much takes everything out of your water. So you can do your chlorines, your nickel. I mean, I'm not going to read them all, but it takes care of pretty much everything. And I know someone's thinking like, well, just get rid of softeners and get rid of all the other crap and just have an RO system. It's done. It takes away 99.9% of everything, which gives you that 100% pure water. All right. But if you've done any sort of water quality, you're going to know that 100% pure water is actually extremely dangerous for your system and also for yourself. So what's happening? What's going on with this RO? How are we making this the 99.9% pure water? Okay. So what we're going to be doing is we're going to be running through, our stage filters. We'll be entering through there. First one, always going to be our sediment filter. That'll be a nice pleated filter. We'll be collecting any sort of rust, debris, dirt, any solid debris that are coming in. We're able to grab on and hold on to that one. After we go through that filter, we'll be entering into our carbon block. Again, carbon is going to start absorbing a lot of the impurities out of the water, or not the impurities, maybe the chlorine that we've added to that, okay? We're going to be absorbing that out. Once we get through those two processes, now we're going to go through the RO membrane, and this is the brains of the whole operation. I'll tell you, your carbon and your pleated are very important, okay? But this are the brains, and what's happening is we're taking high pressure water and we're pushing it as hard as we can through a piece of rubber with beyond microscopic holes, okay? And the holes are so small that we're able to remove sediment and dust, but we're actually able to take chlorine, even microscopic things through it, okay? But it takes a while to press through, okay? And knowing this, just remember, between 75 and 80% of the water that you're running through your RO goes to drain. You only hold on to about 20 to 25% of your water, okay? So if I'm dumping 100 gallons into our tank, remember, I'm only getting a 5-gallon bucket out of it, okay? Because most of the water is made up. We've got a lot of stuff in our water that's not bad for us, but with RO, we want it all out. We've decided for some reason we wanted everything out, okay? But once it gets to that membrane, we're good. Now we're going to go up through our fourth stage, okay? And our fourth stage is just what we call a polish filter. It's just another activated carbon filter. Kind of just gives you your last little wipe down. It kind of like when you wipe that table down for the last time, that's your last little wipe down. Just clean it up, send it out. We know we're in good shape. So I will tell you, we've gone through the process and you're saying, dude, how's that dangerous? We're just filtering it all out. Anytime you take water to its absolute purest state, all water wants to do is get back to the state it wants to be, okay? If calcium and magnesium, if the water wants that in it, it's going to take it, okay? The way I can prove that is if you look at any RO system, I can bring my standard domestic water in, not a problem, copper, galvanized, you name the material, I can plug it right into the end. All right, we're in good shape. Feed my system with whatever I want. But when we exit this last post filter and we're feeding our fixture, or say we're feeding a piece of equipment, maybe it's a massive piece of equipment. If we would run that in any sort of metallic piping, copper, galvanized, anything that's out there, all right, if you would run that through a copper, you've got about 30 days because water is so pure that as it's running through that copper tubing, it is actually starting to strip the materials out of that copper because water is going to take back what it wants. And it's going to start stripping a lot. So if you do run RO water and on the downstream side, you're using copper, be ready to change it. You've got yourself about 30 days. Okay, it'll eat it all out. So any sort of tubing that you're running RO water, make sure that it's, you're able to do that. Make sure it's a poly tubing. Make sure that there's no metal. That means no brass as well. You can't use brass fittings on that one. So you want to make sure that we're running it and everything's going poly through it. Even the faucet that you're buying with it, it's a polyline spout, okay? That water cannot touch or really be around the metal because it will start leaking. Now, I went through all that and I said, we talked about the dangers of, hey, it's going to pull it back. So if it's going to draw all the minerals and any of the stuff out of the copper or any metal, what do you think that's doing to your body? So when you drink that, what's happening is people that are using, and this is the new thing, let's drink RO water because it's the best. the RO water will start drawing calcium, magnesium, and a lot of vitamins and minerals. It's going to draw it out of your body and into that water. So people, if you're using, or if you know someone that's using RO water as their primary drinking source, tell them to be careful with that one. Most of the time, you'll find them if they're extremely vitamin deficient, things like that. That's most likely because they're just drinking RO water. I'm not saying it's going to happen guaranteed, but just be aware of what can happen when you drink it. So, but you're saying, Todd, I want to drink this. I like this stuff. Okay, fine. Let's use it, but let's use it like a Starbucks. Actually, a guy named Jeff Kiko, a wholesaler. They don't teach me much, but this guy taught me this. RO water, when you get into and you jump into Starbucks, why? I just started drinking coffee 3 months ago. But when you drink coffee at home and you drink coffee at Starbucks, everyone says, hey, Starbucks is so much better. It's got so much more flavor. And that is because they're using RO water. If you take standard potable water that you've softened and you've treated, whatever you want to do, and you dump it over your coffee grounds, it's actually just running over top of it. And it's just kind of grabbing off whatever taste it's giving you, and it's dripping into your pot. When some of these companies are using RO water, when that RO water is draped over top of the bean, it's not just grabbing what's off the top, it is actually sucking everything out of that bean. So you're getting everything out of that coffee bean, which is giving you a lot more flavor to it because it is physically pulling. It's saying, nope, you don't get it, I get it, and yank it back. So again, I'm not trying to scare anybody for RO water, but if I see anything that could cause health issues, I always feel I should bring it up, let people know. If you're using the RO water, let's just look at it as, hey, this is going to be for my coffee and tea. Hey, this is going to be more for, maybe we're making makeup, and that, the chlorine and anything in that water could change the color, the consistency. So our water is great with manufacturing. We don't have to worry about, maybe my plastic turning a different color or something else changing in a different way because, things in the water are changing it. But, giving it our water, that is pretty much as clean as you can possibly get it. We're just taking everything out of that water. But again, just make sure we're using it in the right positions and understanding what we're doing with it. And the other big one, when we're using water storage, or when we're using RO, we have to have water storage, okay? That's either going to be in the small tank. That's nothing. If you just turn on an RO and turn on a faucet, you will get 0 water, okay? It takes time. We need to fill that storage tank because what we're doing is we're using the water that's in the storage tank. That's your RO water because it takes so much time to pull all the imperfections out. So now we got our total water quality system. So we're trying to design our system. We want to look at this as, what's next? What should we do? I've got my water test. Now I want to build it, okay? When we're building it, we want to make sure that, hey, listen, we want to jump in with my test results. I've got a lot of rust. I've got a lot of things in there. I'd like to filter that out, Let me know the water. Let us know what's in that water. We'll help you choose what's the best filter to get rid of, because every water is different. We'll help you choose that right filter. Okay. So once we get our filter, now we get to make our choice. Are we going to be using, say, a water softener, or are we going to be jumping down and using a water conditioner? Okay. Once you make your choice, then we're able to jump over to our basic point of use. And that can be something as simple as just a small 2-stage drinking water, even something as simple as our refrigerator. Did you guys know there's filters in refrigerators? That little light that's red on your refrigerator, I didn't know that tells you you're supposed to change your filter. So I learned something too. And the last one will be an RO. So even something as simple as a refrigerator all the way up to a massive manufacturer RO system is a complete system, okay? Now, I'm not telling you every system has to have filters, have to have this, but knowing your system, getting that water test, either you can send it to us, we'll test it. You can send it out. You can even stop by any sort of pool house and for free, they'll test for your water for you and give you your results. You can get that over to us and we'll help. We'll say, hey, listen, there's not enough in the water. Don't waste your time putting a big filtration system in it. You're good. I think we can just go right to our softener, or maybe just go right to our conditioner, whatever's going to work best. And really, it's what does the end user want? What's the result that end user is looking for? And that's really how we're going to be building all this one. So I haven't seen any questions. I'm about 10 minutes faster than I should be. Hopefully you guys got a lot of questions. If you don't, I'll have Jim jump in on the computer.
Hey guys, just 1 second here. Just take a look.
Those can't all be questions.
No,
Okay.
no questions.
All right, well, there's no questions. I get it. They're webinars. Nobody wants to jump out. But as the days go on, or as the time goes on, if you have a question, reach out to us. It's our job to answer, to get you guys the right information. So if you got questions, or if you have a project or something, somebody calls you, reach out to us. We love to help you out and jump into the water quality aspect. So guys, I appreciate it. I'll turn it back over to Jim.
Yeah, thanks everyone for jumping on today. Hope you join us for our next one, which will be in June, covering bottle fillers and water coolers, hosted by Oasis.
Not Todd.
Not Todd. So thanks again, everybody. Hope you have a good day. See you next time.
Real quick there, Todd, before you jump off, somebody in the chat had a question about sulfur.